Hey everybody, thanks for joining us for the last session of the day. Arguably the most important session, talking about resiliency in the cloud. Strengthening your organization's resiliency and data residency with Canada's, the second Canadian region. So as many of you know, we recently announced the Calgary region, which is going to be coming online later this year, early next year. As a result, a lot of organizations are going to start, in Canada, are going to start looking at how they can increase resiliency and leverage that new region. So that's what we're going to focus on today. We'll talk about concepts like high availability, disaster recovery, all kind of dimensions of resiliency. Just to do a quick introduction of myself, my name is Rick Grimaldi. I'm a solution architect at AWS. I've been here for about 3 years. Before joining AWS, I spent a lot of time kind of in the backup and disaster recovery world. So started in kind of operations, in the data center, pulling tapes out, supporting customers with restoring from backup, from tapes, kind of all that good stuff. And then kind of transitioned more into professional services and then eventually an architecture role. So now at AWS, I'm part of what we call a technical field community, supporting resilience. So I work with customers all over the globe as they build out resilience strategies for their business. So it's good to be here.
Hi everyone, my name is Colin Lavallee. I'm an AWS Solutions Architect like Rick here. I've been with AWS for about 2.5 years now. I've been in the IT industry for about a little over 25 now. And over that journey, a lot of that has been around storage and backup and resiliency, building resilient architectures, storage area networks or applications, all those type of things. And yeah, it's been great here to have this session with you and discuss the resiliency in the cloud. So I'll turn it back to Rick to get started, and I'll do the second half of the presentation. Okay, Rick.
Great. Okay, so let's talk about traditional disaster recovery. So oftentimes when people think about disaster recovery, we think about flooding, we think about floods, probably more recently we think about fires that are effectively going to take down our primary data center, take down our applications. If you've been around for a while like me, working in data centers, you've probably spent some time around LTO tapes. I spent a lot of my early days of my career pulling those out of tape libraries and shipping them off-site so that we can recover in the event of a failure. And that usually meant bringing them back on site, rehydrating that, bringing up your application. It could take days, sometimes weeks to bring up those applications. Obviously, as technologies got better, we started relying on high-speed networks and better replication technology so that we could replicate between sites. And that's kind of what you see in the bottom right. But even at that point, disaster recovery has always been viewed kind of as a last resort. You don't want to hit that big red button in the middle unless you absolutely have to. And with organizations big and small I've worked with, they're always very apprehensive to do that. Now with obviously the cloud, things have changed a little bit, and that's really what we're going to dig into today. And we're going to talk about how you can stay resilient without viewing availability or resiliency as this kind of big, dangerous red button that you have to hit. So if you look at resilience through an AWS lens, this is kind of the mental model that we use to explain it. So on the left-hand side, we have high availability. And this is resistance to common failures kind of within a single site, right? So this is doing things like deploying multiple, fault-tolerant versions of servers or using load balancers to distribute load, while DR is kind of recovering to a completely separate site. And this is really what we're going to focus on today, because as many public sector customers in Canada that have data residency requirements, you've kind of been constrained to a single region within Montreal. But now with Calgary becoming available, the paradigm has kind of expanded, and now you're able to build multi-region disaster recovery strategies. The other interesting part is on the bottom here, as organizations are modernizing and developing their applications, leveraging CI/CD practices, that becomes part of the conversation as well, because now you don't need to necessarily bring up a copy of your server. You can pull down all of your code, deploy your containers, and get your systems up and running without needing to worry about too much there, other than the persistence of the underlying data, which still kind of falls into those other two categories. So that becomes a really important piece of this puzzle as well. So if we talk a little bit about what are the benefits of doing cloud disaster recovery in the cloud, I remember in my early days and last company I worked at was a partner that provided data protection solutions. This is low-hanging fruit for cloud, even if you're on-premise today. If you think of traditional disaster recovery, that usually meant massive upfront investment in servers. You need to procure another disaster recovery site. You need to deploy networks. I remember being in there, racking and stacking gear. Every time you expanded your production, your disaster recovery would have to expand too. And then, that data growth becomes hard to manage. It's hard to test without actually doing business, having a business impact. So, being on calls at 2 o'clock in the morning, doing that DR test, which has now turned into an actual DR. I've been there as well. So it's, again, still that kind of big red button. And then, management of infrastructure overhead. If you have, global distribution or even distribution across a country like Canada, you have to worry about multiple data centers, potentially multiple DR data centers, multiple networks. It gets more complex and harder to manage. And this is a classic one I used to see all the time was your DR infrastructure falls behind where your production is because you're worried about patching your production and keeping it up to date. DR is less focused, and as a result, it leaves you open to cyber attacks, vulnerabilities in the code. Now, obviously, if you're talking about DR in the cloud, you don't need to put any upfront hardware investment. We'll talk about different models. Colin will take us through that in a little bit. But you pay as you go in the cloud, so you only spin up those servers when you need them, and obviously lower IT management overhead. AWS takes care of a lot of that. We're managing, the underlying infrastructure for you. You don't need to worry about running firmware patches and all this kind of stuff that you would need to worry about on premise. Much more automation, infrastructure as code. Technologies like Ansible or Terraform can really help you, run these DR drills at scale. We also have some services in AWS that can help you with that as well. Excuse me. Simple and repeatable testing, and really takes you from minutes, not hours or days to actually execute on this. And this is something I've witnessed working with customers in the cloud versus I've had my days in the trenches. When a storage array goes down at a customer site and trying to get things back up and running and scratching your chin and saying, do we DR, right? Or should we try to get the storage array fixed? So obviously it becomes a much easier conversation when we're dealing with infrastructure in the cloud. So there's two key terms that we talk about, and many of you might be familiar with this, but when it comes to business impact, we think about recovery point objective, which is the amount of data loss that you can sustain in the application. And then we think about recovery time objective, which is how long can the application be down for. The trickiest part is getting your different groups and lines of business to agree on what this needs to be for an application. So we're going to talk a little bit about that. How do you map that to your application and between your application and your business? But these two metrics are ultimately going to define how much it's going to cost you and which strategy you should adopt in order to build a DR and HA strategy. Many of you are probably familiar with the AWS region design. So we have the Montreal region today. Within that region, we have what we call availability zones. You can think of them almost as fault planes. And we ask our customers to deploy across them in order to achieve high availability and fault tolerance, as well as expand their scalability. And each of those availability zones actually consists of a cluster of one or more data centers that each has its own independent networking, power, cooling, and diverse fuel sources. So the idea is that if you can distribute your applications across these availability zones, you can achieve high availability within that region. We'll talk a little bit more about how we expand beyond that. That's obviously the focus of the session today, is how do we leverage that other region. But we will kind of cover HA concepts as well. And the timeline for Calgary West later this year, early 2024. So this is something customers are actively starting to think about and look at. So the Calgary region, for those of you who haven't really heard, obviously is a significant investment from AWS in Canada. I think $21 billion investment through 2037, $39 billion in GDP, and more than 5,000 FTEs, full-time equivalent jobs. So this is obviously a huge investment by AWS in Canada, but you as a customer gets to benefit by now taking advantage of this second region. Maybe if you're on the West Coast, obviously that's good from a latency perspective and keeping things a little bit closer to you, but it's great from a resiliency perspective, being able to leverage that additional region. Now, I mentioned our availability zones before, and oftentimes customers will ask us, well, how far apart are those availability zones? And the answer is within 100 kilometers. And the reason we do it that way is because we shoot for this Goldilocks zone that you see here. So the idea is we want to be close enough between these availability zones that we can achieve synchronous replication of data. The example I always use is Amazon S3. So when you write an object to Amazon S3 standard, it actually is replicated across 3 availability zones. If those availability zones were too far apart, that would mean a higher latency, which means it'd take you longer to write to that bucket. So we want to keep them close enough together that we can achieve sub-millisecond latency, but basically far enough apart that we're not going to have issues of flooding, fires, tornadoes, hurricanes, affecting all of those availability zones at the same time. So there's a lot of planning and a lot of thought that goes into where we build these and how we build these. And we look at things like floodplains, we look at classical weather patterns, all of this kind of stuff. But ultimately, we always need to kind of shoot for this Goldilocks zone if we're going to be able to provide our customers the ability to deploy highly available applications. And we see on kind of to the right of the Goldilocks zone is really what we're talking about when we're talking about multi-region. Massive issues or a total regional outage. And you need to plan for that if it's your business critical applications that you can't afford downtime. The other thing, I've seen a lot of over the years when I'm working with customers, you'll read through some of these business continuity plans or DR documents, and they'll have language in it that says something along the lines of, keep your tape backups 10 kilometers apart at different sites. Make sure your data centers are at least 50 kilometers apart. But that doesn't really mean anything, right? That's an arbitrary number if both of those data centers are actually on the same floodplain, right? Or can be affected by the same outage of a power grid. So the distances are less important than making sure that those are true, independent fault planes. And what we work with our customers to identify is what is the business requirement? So in this example, it's 1 hour. The business cannot tolerate more than 1 hour of lost services, should never lose more than 60 minutes of data, and the service needs to be available 24/7. That's actually a requirement that we can take back as architects and as engineers and build a solution around, right? And we can do that in the AWS Cloud by deploying this to multiple availability zones, using load balancers to distribute between those different availability zones, and then using things like HA databases, as well as, like I mentioned before, using CI/CD blue-green deployment practices so that we can shift traffic as we're updating and patching our systems to maintain that 24/7 uptime. So that's a tangible goal that we can actually wrap our hands around. So I was talking before about, how do we get to the RTOs and RPOs for our applications, which are on the right. So on the right, we have all of our applications listed. On the left, we have all of our different lines of business. And I've been through a number of these exercises with customers, big and small, and it's never an easy conversation, right? Because every line of business, every group within the organization is going to say, my application's critical, and I need, basically 0, 0. But you have to work through it. You actually have to think through it because there's a cost to doing that, and you obviously need to balance that. So by working with those different lines of business, you can come up with their service RTOs and RPOs for each of their lines of business. So this is the common way to do it. And then say a system like your CRM, which is relied on by sales, finance, and HR, you're going to take basically the lowest common denominator of those, and that is going to become your application RTO and RPO. And this is what your IT teams are then going to take and design for and solution for. Usually as you go through a business impact assessment, one of these exercises, you'll also try to quantify the impact of the business, whether it's financial or legal or customer impact as well. And that's also to be considered, and sometimes that'll sway RTOs and RPOs in one direction or the other. But having this kind of mapping and strategy is a great place to start when you're trying to identify where to shoot for your applications. And availability is not free, right? So the whole reason why you need to go through this exercise and you just say, okay, well, let's just shoot for the best possible RTO and RPO is because there's a cost to doing that. And Colin's going to go through in a minute and show us what that kind of looks like. But ultimately, you need to optimize your strategy with the requirements of the business. So let's talk a little bit about high availability. And if you're an AWS customer today, and you're running business critical applications in the cloud, you're probably already doing this. But the idea is you want to design for an availability zone failure. So like I mentioned, that's a kind of a fault plane within AWS. So that cluster of data centers goes down, that availability zone goes down, you want to make sure that your application can continue to operate. If you look at the top right there, you'll see basically multiple availability zones. Availability zone A goes down, which is running some servers. This is, effectively a two-tier application, app database. We're actually running our primary RDS database in that availability zone. So what happens when this availability zone goes down? Well, our secondary in availability zone B database becomes the primary, and depending on what flavor of RDS, what engine you're using, that time might vary. But basically within minutes, you should be able to get that database promoted to the primary. And then your load balancer can automatically start redirecting traffic to that second availability zone. So this means that you effectively have an RPO of 0 and an RTO of maybe a couple of minutes. Well, that's great. That means you didn't have to do very much to kind of achieve that. And then, of course, if the same thing happened in another availability zone, you'd be able to do that as well. And we're able to use auto-scaling groups in this case to spin up additional instances. So if two servers can't take that load, we can spin up another server in availability zone B and continue business as usual. So this is a very common pattern. So we always ask our customers to leverage these availability zones in order to build a resilient application. And at the bottom, you'll see, on top of this, I'm a guy that comes from the backup world. You'll still want to take backups of everything, right? You'll still want to take snapshots of your EBS databases. We write those, EBS storage. You'll write that to S3, which, like I mentioned, gets distributed among multiple availability zones by default. You'll also want to do, point-in-time backups of your DynamoDB databases, for example. And then services like S3 actually have versioning. So you can version and then roll back to different versions if you want as well. So leverage all of these different things in order to kind of achieve that resilience strategy. Now, if we expand this to multi-region, you'll see, in this case, the entire region goes down. This never really happened for AWS, but if that entire region goes down, we need to figure out how do we redirect it. And what you'll see on the right is usually what you would consider a tier 0 business critical application, because you're effectively building this in 2 regions. And you can think of the top as, say, Canada Central and bottom as Canada West, the New Calgary region. So here we're actually using Red 53 to direct the traffic to one or the other. So if we lose that entire region, we can actually promote that database at the bottom, one of those standby RDS databases, and redirect traffic via Red 53 and bring that whole application up in that second region. The thing you have to consider, though, is when you're further apart, like I mentioned, there's going to be larger delays in terms of replication for databases. So that RDS database isn't going to be a RPO 0. It might be an RPO close to 0, but you're going to basically be asynchronously replicating that database. So again, that's a limitation of the speed of light, right? There's not much you can do there because you can't have all of your transactions pivot on writing to a database that's thousands of kilometers away. So something to consider, but you can really achieve regional high availability. And you'll see a little bit of overlap when Colin talks about DR strategies later between this and kind of an active-active, which is more or less kind of the same architecture that kind of bleeds into both HA and DR. Okay. So with that, I think I'm going to pass it over to Colin to go through the DR strategies in a little bit more detail.
Thanks, Rick.
Yep.
Okay, great, thanks. So I'm going to talk about DR strategies. And so in terms of DR strategies, Rick talked about business impact assessments in an earlier slide. And as a result of those business impact assessments, you were able to identify your RPO and RTO. So with those RPO and RTOs, then we can determine which DR strategy that we would use. So the very first one here is backup restore. So this is for those those applications that you would need to have a recovery point objective or recovery time objective of hours. So these are for lower important applications, but you still need to have a backup strategy for those applications. So as you can imagine, from a complexity point of view, this is the least complex option and the least costly option. The next option is Pilot Light. So this is for those applications that have RPO, RTO of tens of minutes. So these are more important applications, but still not business critical applications, but you still need to have a strategy to recover them quicker than backup and restore. So the idea with Pilot Light is you're going to be replicating your data from your primary location to your secondary location, but you're not going to have any of your applications running there. You're just going to have the core services to support your application in the other location. So again, from a scale, a little more complex than backup and restore, and a little more cost in terms of backup and restore. The next one is a warm standby. So this is for those business critical applications that you need near real-time recovery. So this is in the minutes of RPO and RTO. So in terms of what you need to do for this is you're going to be setting up a subset of your application in another location. So you're going to have your primary location, you're going to be replicating your data, and you might have a subset of your applications running there to be able to quickly fail over to that second location. And then the last one I have here is hot standby or active-active. So this is for those applications that you cannot have any downtime whatsoever. So as you can imagine from the scale perspective, this is the most complex and is on the cost scale is the one that costs the most out of all these 4 different strategies. Now, I'm going to go into each of these and provide examples on the next slides, but I also have links to blog posts that actually go over these different strategies and also goes into examples for each of these DR strategies. So you'll see that at the end. So the first one I have here is back and restore. And as you remember, this is for those 4 hours in terms of recovery time objective and recovery point objective. And in this scenario, I have a simple application. It's just running in one availability zone. So I have one compute instance, so that's like a VM or in the cloud. And I have an EBS volume, which is Elastic Block Store volume that contains the operating system and the application software installed on it. So that's what you see in the top left of the Amazon VPC there, the Amazon EBS volume. And in order to back that volume up, I'm going to take an Amazon EBS snapshot, and I'm going to store that into our Amazon S3 service, which is our simple storage service. It is a highly available, durable, scalable object storage service that is designed for 11 nines of durability. And this service is highly available in the region, so you don't need to worry about replicating your data within a particular region. And then I also have my Amazon EFS volume here. Amazon EFS is a serverless file server service that allows you to share data without managing storage capacity, provisioning or managing performance. And what we're going to do, and this is, think of it as like a NAS, so this is shared storage. So we're going to be backing that up with AWS Backup. And then at the bottom here, I have a database. So I have Amazon RDS, which is our relational database service. And that we're going to be taking our snapshot of that database. And again, we're going to store it in Amazon S3. So now we have our backup copy in our primary location. And then what we're going to do is we're going to replicate that to our second region that you see on the right. So now I have 2 copies of my data in 2 different locations. So now you can imagine that we have an issue with, there we go, an issue with our primary region, availability zone 1, where our application is residing. And then what we would do is we would restore our EBS volume from the snapshot we have. We would attach that to our EC2 instance. We wouldn't have to restore our EFS volume because that is highly available in the region. So we just need to connect that back to our EC2 instance that we have. Then we would restore our Amazon RDS snapshot. And then now at this point, our application is available again. So we've now been able to restore our application. And this steps can be manual or can be automated to help increase the recovery time. Now, let's imagine that we've lost our entire region. So now we have to do the same thing in our second region, but this time recovering from our secondary copy. So again, we would restore our EBS volume. This time we would have to restore our EFS volume because it's in a different region. We didn't have that running there, so we would restore our EFS volume, attach those both to our EC2 instance, and then we'd recover our database. So at this point in time, now our application is available again in our second region. So again, this whole process can be automated or manual, and this is meant for those lower impact applications that have RPO-R2 of hours. The next one here is Pilot Light. So in this particular case, if you look at the left of the region on the left, the Canadian Central region, this particular application is a little bit different. It's a highly available application that we have spread across multiple availability zones. So we have ELB in the front, which is Elastic Load Balancer, to be able to load balance our traffic across these two availability zones. We have our EC2 instances, our compute instances, in an auto-scaling group to be able to scale as demand for our applications. So that's our front-end server, and the same for our application servers. So it's highly available and scalable in those auto-scaling groups. And then we have a highly available database. We have a primary database, and we have read replica in another availability zone. So in the event of something happening in one of those availability zones, we can fail over to the other one. So now that's a different architecture. Now for the Pilot Light part, what we have is a read replica in our second region. So now we're replicating our data to our second region. So our database is there, but if you look at the next part where we have our auto-scaling groups, we don't have any compute instances there. We have our auto-scaling group configured, but they're turned off. So this is going to save you on costs. So you don't have to pay for those instances running all that time, but you have your data there, so it's going to be able to give you that tens of minutes availability to recover. So in the event of a disaster, it'll help you with that process. So this is the part of the Pilot Light is mentioning where we need our core services there to help accelerate our recovery. So in the event that we did lose a region, so then what we would do is we would promote our read replica that we have in our second region. We would create another replica in another availability zone. So now our database is highly available in that second region. Then at that point, we would turn on our EC2 instances for our front end and for our application servers. So now our application would be available in our second region. So at this point in time, so now all of our items are restored, our application is running. Then what we would do is we would either manually or automatically configure our DNS entry to point to our second Elastic Load Balancer in our second region. So we can set up the Route 53 to with health checks to automatically fail it over, so it would automatically detect that your Elastic Load Balancer is unavailable in the primary region, then fail over to the second region. And just to mention here, our Route 53 service is a global service, it's not a regional service. So this lives within the AWS Cloud as a whole. And it is our only service that we have that has an SLA of 100%. All right, so that's Pilot Light. So the next one I have here is Warm Standby. So as you can see here, the primary region is set up as similar. The strategy is really similar. The only difference is here we have a subset of our application running here. So in the event of testing, you can actually test your application so your application is available, and you can test it before you actually fail over. And in that particular case, you know that your application is available and ready to fail over. So you don't have to worry about, will my application actually work when I do fail over? So it's a similar situation here. If you did have a failure, you take your database, you promote your secondary database to the primary, then you would set up your read replica in the second availability zone, and then at that point, you would scale out your application servers and your front-end server to be able to accept the full load of your applications. And then the last bit, again, is you update your DNS entry. So again, this could be an automated or a manual update to your DNS to repoint to the elastic load balancer in your second region. So this is for near real-time applications that think of it as like a business critical application that you want to be able to quickly fail over. And the point is here that you have a minimum available number of services there to be able to accept a load to immediately be able to handle, well, not immediately, but near real time be able to handle the recovery process. And the last one I have here is multi-site active-active. So in this particular case, I have a full set of my application in both regions at the same time. So that is, you can have it set up where your application would be able to accept traffic to both locations at the same time, as I mentioned. And the database here, you notice at the bottom is a little bit different. It's a DynamoDB. This is a regional service. It's a serverless NoSQL database. And we have set up in this particular example as global tables to make it read-writable in both locations at the same time. And another part to this here is you can set up routing for Route 53 to set up with in terms of geolocation. And geolocation is basically where, let's say you have customers that are accessing your website from the East Coast, and then they would get redirected to the region that's closest to them, so they'll be Montreal. So if you have customers on the West Coast, and then they would connect to your service, they would be redirected to the West Coast. So Route 53 has a number of the different routing capabilities. We also have latency based, so if it determines that your latency is lower going to a particular location, then it would redirect you to that particular location. So Route 53 has a number of other ones as well, but that's just some examples. All right, so next thing I want to talk about is Resiliency on AWS. So I'm not going to go through each one of these services that we have here, but I do want to call out a few different services. The first one I want to call out is Fault Injection Simulator. So I don't know if you heard of chaos engineering, but basically it's the idea is you're going to inject faults into your application, and you're going to determine whether it is going to behave the way you expect it or not. So for example, I have an auto-scaling group. I have 2 EC2 instances in it, and if one of those should fail, I want to automatically create a new EC2 instance, so I'll always have 2. So you can run a fault injection simulator test by terminating one of those instances, and if it recovers, great. My auto-scaling group is configured properly, and I don't have to worry about anything. I know that that functions properly. But if it didn't, then you know that, okay, there may be something wrong with my auto-scaling group, so now I have to go back, and I'll have to check my configuration, make the necessary changes, and then at that point, I can go back and I can test again. And then if it works, great, fantastic. My auto-scaling group is configured properly. So with the fault injection simulator, you can do a number of other tests. You can do CPU stress testing, memory stress testing, network stress testing. You can even create your own custom actions to perform different, inject different faults into your application to ensure that your application is going to behave properly when you actually do have some sort of issue. The next one I want to talk about is the AWS Resiliency Hub. So what this is, you can create resiliency policies, and then you can run assessments against your applications to determine if they're going to meet those policies or not. And then based on that output, if it meets those policies, great, it's as designed. But if it's not, then it can send you an alert saying, hey, you know what, this is not meeting my policy. Then you can take action and make it sure it meets your policy. So for example, if I have a Amazon RDS database and I want to make sure that's highly available, so I have an active standby database configuration in my policy, but if I go and run an assessment using that policy and it identifies and says, oh, I only have a primary database, but I don't have a standby, so then it will alert you saying, this application is not meeting the policy that you have set, so therefore you can make the corrective action to add your standby database. And the last one I want to talk about here in this particular slide is Amazon Elastic Disaster Recovery. so DRS for short. And this is a service that allows you to help you build and create automated recovery processes. So let's say if you have on-premises applications that you want to improve your recovery process, you can replicate the data to AWS to be able to create those instances. You can run automated tests, or you can use automated failover to automatically fail over to AWS as well. So it's a great tool to help you recover in the event of some sort of failure. Yeah, so that's that one. I think that's all I want to talk about in this slide. The next part I want to talk about is networking in multi-region configuration. So before I get into the multi-region configuration part, I just want to explain what it would look like in a primary region. These are just an example, like depending on your requirements, it will possibly look differently. But you'll see that I have 3 VPCs here. I have a security VPC, then I have 2 VPCs with workloads. A VPC is a virtual private cloud. So this is a logically isolated network. And when you create your VPC by itself, it's not able to communicate outside of that VPC. So you'd either have to set up a VPC peering connection, or you'd have to create a attachment to a transit gateway, as you see here. So with a transit gateway, it acts like a cloud router. So it enables you to route your traffic between these VPCs. And you'll see here I have a data center in the bottom here with a direct connect connection. And that's a private connection that you can establish to AWS to attach to the transit gateway. And the same thing with branch offices that you would say you want to connect over the internet via VPN. So again, you can create an attachment to a transit gateway, and then you can route your traffic from on-premises to AWS, or from AWS to on-premises. And then when we introduce the second region, same idea. You have your VPCs, your virtual private clouds, for your networking to deploy your resources in. You have your transit gateway to route your traffic between those VPCs. And in this example, I have another data center. I'm using Direct Connect to connect to that other transit gateway in the second region. And then I want to be able to connect these 2 regions together. So then what you would do is you can create a transit gateway peering connection. And this peering connection is a highly available low latency link, or links rather, between the 2 regions. And all you need to do is go into the AWS console, and you can provision these attachments, this peering connection between these 2 transit gateways. And within minutes, you can have a multi-region configuration between these 2 regions. So now you can be able to route traffic to from each region, or to from the on-premises to AWS. And next I have a couple of customer use cases. So the first one I have here is Calvert Health. They're a not-for-profit community hospital, and they wanted to improve their recovery process. So they have medical records for patients. So you can imagine the patient data is very important. To be able to treat patients, you need to be able to have access to that data. So with that, they decided to use the AWS Elastic Disaster Recovery Service, and they were able to reduce their recovery time by 97%. So they originally had a recovery process that was taking over 72 hours, and they were able to reduce that to less than 2 hours. So it greatly gave them confidence in their recovery process. The next one I have here is Thomson Reuters, which is a financial organization. So they provide financial products for banks or for customers. And they had another location for the recovery process before, and they want to improve and reduce costs for the recovery process. So in their previous location, they had to procure all of that hardware. They had to pay for all that up front, because when you recover, you need to be able to have those resources be readily available in the event of recovery. So again, they were able to leverage disaster recovery service, and now they're replicating their data. So they've configured this with over 300 servers, and over 120 terabytes of data. So they're replicating this to AWS. So the data is there, so they're paying for that, but you don't have to pay for the servers at this point in time. You only need to pay for the servers when they actually provision them. So when they have time to recover, so then they just recover. They can automate the recovery process of those servers that they have with the data that they have in AWS, and then it quickly accelerates their recovery process. And by doing this, they were able to save on those costs because, as I mentioned, those servers are not there at this point in time. You're only provisioning them at the time of recovery. And I did mention about these, the blog posts in terms of these DR strategies that I talked about. So the first one, it talks about the overall DR strategies. And then there's the examples of each of these blog posts that goes through each of the DR strategy in detail that I went over. So you can take these as references documents, and if you want to learn more about these DR strategies. So with that, that is it for our session. So thanks for everyone for attending this session. Really appreciate it. So if you have any questions, feel free to ask any questions, or Rick and I will be here to, yeah.